So we're going to move now into a little bit about wood science and how you can avoid things like cupping. That only happens when there's more moisture underneath the wood than on top. And how to use proper vapor retarders, or when you need to use a vapor barrier to avoid having water come up and get into the wood. Wood really has these long cells that love to take on and give off moisture. The free water inside the wood cells goes away when we kiln dry the wood. The cellulose in the wood cell is what loves to attract and give off moisture with changes in relative humidity and temperature. So we're going to show you how to properly seal the wood and really make that be a seasonal process so that you're not having to worry about, you're at the beach, you can open the doors during the day, close them up at night and turn on the air conditioning, and the wood will be just fine. We talked a little bit about the vertical grain that tends to shrink and swell less than the plain sawn. Certainly that has something to do with the width, but it is the grain orientation. And our COO tells us there are about 8 different predominant theories, and the one that nobody really knows why this is so, but it seems most likely to do with some of the ray cells that go out from the center of some species, like the spokes of a wheel, and the longleaf pine does have those. So wood tends to shrink and swell across the face 50 to 100 times more than down the length of the board. Now what happens when you engineer wood is you're cutting down the shrink swell 5 times across the face, but you're making it tend to shrink and swell 5 times more down the length of the board. So while we'll give you 12-foot or longer pieces in solid wood, we're going to tend to stop at about 8 feet in engineered. It will have a wear layer equivalent to your solid wood, and it will have the same average length. Here's a lovely chart right out of the Wood Engineering Handbook. That is how you figure out what your wood should be installed at. This is the most important tip, to bring that wood on site when the site's ready, if you can do that. So here's an example. If you have expected average temperature in the life of the building of about 75 degrees and average relative humidity of about 45%, then you would want to install your wood floor at about 8 or 9% moisture content. Now you would want the subfloor to be no more than 2% higher. The Wood Floor Association used to say 4% difference was okay, and today they'll say that if your floor is over 3 inches on the face, that should be no more than 2% higher on the subfloor. So I arrived after the wood had been delivered, and we had shipped the wood at about 8 or 9% because that's what we expected for this hunt lodge, where they wouldn't be there some of the year, but they did have some dehumidification. Now, unfortunately, when I got there, the plywood was measuring 16%. Fortunately, it was plywood. Advantech's a great product, but it just does not hold nails well enough. Try it yourself sometime. Take a piece of wood floor and nail it to a piece of plywood, and nail another piece to a piece of Advantech, and see which one you can pull off. But this was the plywood, and it was easy enough to dry out the site by turning on the heat because it was wintertime. So once we got the plywood down to the 10 or 11% that we needed it to be, of course the wood was too dry. So I'm going to show you, my favorite thing to show architects is a formula on how you can calculate what wood will do, how much it will shrink and swell. We did help the builder with a vapor retarder. This was on a crawl space, and that hot humid air can get into that crawl space and let off the humidity. So you want to use something like a bituminous layer with 2 layers of craft paper on either side that tends to slow down the moisture and not cause problems. A lot of people think roofing felt is a good product to use. It actually does nothing to prevent moisture movement. And you don't want to use plastic, which will trap the moisture. So you use something like a product called Aquabar B. It's made by Fortifiber, and it has a permeance rating of halfway between the roofing felt, and the plastic. So it lets moisture move, but very slowly. So we prepared the builder for how we were going to get this floor in right. Concrete's a wonderful product. I actually love it. When we pulled up my friend's laminated floor that had some formaldehyde, we just painted her concrete. Unfortunately, the meters that most people are used to for concrete don't really tell you much. It turns out that the plastic mat tests are a good indication if you have a serious problem. The impedance meters that just sit on top of the concrete are going to measure the top 2 inches of the slab, and the calcium chloride is going to measure the top 2 centimeters. So if you have moisture down deep in the slab and you don't use one of these type moisture meters, this is called an ASTM 2170, I think we're up to -11 now, and you have to drill a hole 40% of the depth of the slab. I clean out the dust and put some mastic over the hole to let the heat dissipate for a little while, and then put the probe into the hole, or what I think is 40% of the depth of the slab, and then get a reading. When our business evaluator called and wanted to show me a video that he said was amazing, and his irrigation system had punched a hole in the soffit and was pouring water into the kitchen of his home. So he called in the restoration folks, who pulled up part of the floor and put in dehumidification for about 3 days, and then said he was ready to go. So when I took this meter and I drilled 3 holes, one in the kitchen, dining room, and hallway, you want 3 per 1,000 square feet. It was interesting that the one furthest away from the leak actually was reading the highest. It was reading 89%, not the 75% that the Wood Floor Association says is the highest you should get before applying a wood floor covering over concrete. In this case, it was easy to turn the air conditioning on and wait about a month for the concrete to get dry enough to use the good glues and put down some more engineered wood floor. If you have to, because of the construction schedule, install over concrete that isn't dry enough, there are some good products. This particular company, Bone Dry, makes an enzyme, and several others make them, that you can spray onto the surface of the concrete. The enzymes find the voids and arrange it so that you can go ahead and install and meet those commercial schedules. You want to watch out to see that there are no surfactants used on the top of the concrete, the kind that would help the screed crews get home without working overtime. And you check that by a bead of water. If it beads up, you've got a problem. If it dissipates to quarter size, you're okay. So if you can't get water to dissipate, you may have to abrade the concrete to get good glue adhesion. This is an installation of solid wood over concrete. There are about 5 different ways to install solid wood over concrete and a couple for engineered, and that will be in your handouts. This particular installation was on a 3rd floor, so we had to be concerned with meeting the sound transmission class. So we used the Sika system. There are several different proprietary systems that will let you glue with the mats and partial glue system versus a full glue system. You always want to ensure that the sound transmission class product is used out into the expansion spaces around the wood and maybe a little up the walls. And you would never want to put any nails through your sound barrier. That will totally eliminate the sound transmission class. A lot of people are still using cork in some of the condominiums, and that's fine. It's a wonderful product. Wood actually transmits sound less than tile or stone. So if you're using the cork, the trick there is just to be sure that you're using the same quality of glue under the cork as you use to glue the wood to the cork, so that you don't tend to get voids and cause sound problems. Here's a picture of some of the better glues in the Sika system. Also talking about Plywood versus the Advantech. If we do install over an Advantech floor, we use a technique of every other trowel width of glue, and that helps hold with nails, holds the floor sufficiently for the long term so the nails don't work out. The top picture is a flooring nail called a cleat, and it's a little bit flat on the bottom so that it tends to shear the wood fibers instead of splitting them like staples can do. Lots of ways to make engineered wood floors. Just know that if you do want a thick wear layer, you might have to put more plies underneath the wear layer than the top example in this image. Reclaimed wood is very hard and may tend to cause the floor to dry cup in winter if it doesn't have enough plies above the tongue and groove under that thick wear layer. The bottom example is showing a balanced milling pattern. However, the wood used on the bottom is not as strong as the reclaimed wood on top and may tend to have similar issues. So, another one of your handouts will be by our COO, how you can ensure that you're getting a well-made engineered floor. It was published in Wood Source magazine.